Okay, today's lesson is continuing our work with inverse normal probability, finding x from a positive z value. Um, so we talked about this last lesson that in the previous lessons we have been looking at normal distribution where we have a real world value which we call x. We need to convert it to a z value so that we can work out the probability. Inverse normal distribution goes the other way. We're given the probability, we need to go work out the z values so that we can work out the real life value. And we started off looking at this problem about Natalie and her grandmother's house, and working out that if she arrives at her house before 4 p.m. 90% of the time, what time must she leave from school? And we put together our graph. We had a go at looking up the table and getting our z value, which is 1.2. The next stage is obviously to calculate x. And the formula we need to know is the following one. Now, that's just a rearrangement of the one that we used in the previous part, looking at the normal distribution, where it was z is equal to x minus mu over the standard deviation. Now, while this equation is the one that's given to you on your exam booklet and your formula booklet in the exam, this one here, which is the rearrangement of that for x, to make x a subject, is not given to you. So it is one that you need to remember. Just as a side note, bit of exam technique, if there's ever formulas you need to remember, probably the best way if you are having trouble remembering them is, while you can't take a cheat sheet into the external exams, you can have one right up until the moment you walk in, and then the first thing you do is just remember that formula and write it down straight away, and just write it somewhere on the cover or anything like that, so that if you have trouble remembering those formulas. So that is one that you may need to look at. And if once we're back on site, if anyone wants to go through it, I can show you how to do it with the rearrangement from the original one. So going back to the question, we've got this z value of 1.81, and we need to convert it to this x value. So x is going to be equal to, first of all, we have the z, which is 0.281. And then we're going to times that by 4, which is our standard deviation. The last thing we're going to do is add 25 minutes. So then we grab our calculator. That gives us the answer 30.124. So the key thing of working out what that means is it means that our z value is 30.124 minutes. So if she on average it takes her 25 minutes. If she was to leave 30 minutes, she would still be late some of the time. So I would say for her to be on time, she should leave 31 minutes early. And because she wants to get there at 4 p.m., that means that it is 3:29 p.m. So a couple of things there. We've got our actual result. Then we have to use a bit of common sense that if she left at 3:30, there would be some, so on our graph, 3:30 or 30 minutes would be there. So there would be still a little bit here that wouldn't be included. So 30 minutes would give us less than 90. Get exactly 90, we'd go 30.12. But I think it's best to suggest 31. Guarantee that she'll be there before 4 p.m. The other thing that's important with these questions is, even though I rounded it, sometimes you need to be more precise with seconds. So 0.124 times 60 seconds is actually 7.44 seconds. So 30 minutes and 7.44 seconds. So it's always good to convert that as well. So just going through those steps with inverse normal distribution, same as before, draw a picture. Like that. Look at the z-score from the table, calculate the x value from the score, and then write the value in context. So always answer the question, basically. Okay, there's some questions in the workbook and in the lesson. Just check that, and hopefully that's easy.